Hello interwebs, welcome to Let's Fix Computers. This popped into the mailbox this week, unannounced, so just a quick note to say that please don't send me stuff without calling or contacting me first, because there's no guarantee that I can do anything with it. I probably actually would have turned this down if I'd spoken to the client first. However, they're actually very lucky because I had a quick look at this and thought, actually, you know what, I'm going to take a swing at this. So, this is an EVGA NuAudio. That's new like new metal. That's, you know, like Linkin Park. Anyway, this is an EVGA sound card and it has a broken optical output port. So let's take this out and I'll show you. I thought this was kind of interesting because, you know, I'm not a big fan of fancy sound cards for computers. I like audio interfaces. I think they're a better solution. Internal sound cards, not really interested in personally. But this one it's a very nice looking sound card. You know, it's pretty cool for pimp value if nothing else. And like EVGA stuff is cool, you know. Everyone loves EVGA. It's a good looking card. Imagine needing SATA power for your sound card. But yeah, so the problem with this one is the optical port, so the SPDIF output is broken. So this guy should have a little plastic out bit and a little doorway on it, and it's broken off on this one. So I don't have an optical cable to hand here, but if you try and insert an optical cable into there, it's not going to hold. It's just going to fall out. What we're going to do is try and replace this. So I guess I'll roll the intro because I've forgotten to do that. What is... I've been watching H-Bomber Guy recently, and so I think smash cuts are funny now. Anyway, so let's open this up and take a look. I've already taken some of the screws off because I wanted to do an inspection just to gauge the plausibility of this repair. Or the feasibility of this repair first. So I'm not going in entirely blind here, hence why half the screws are missing. So, as with many things, this cover is mostly just for show, but there is actually a heatsink here. If we take this guy out, RGB. Come on. Come out. There we go. We have actually got a heatsink on what I'm assuming is the power amplifier there. And the bit that we're interested in is here. So the problem with replacing audio ports is it's really hard to find a replacement jack for the actual thing that you're repairing. This is a major issue with laptops. Just actually finding a bare headphone jack for a laptop is actually quite challenging, which is why a lot of the time we're always fingers crossed that the headphone jack is on an I/O board or a separate audio board, because that separate board usually is something that you can find. So you can just replace that separate daughter board. But for something like this, initially I'd be like, oh, well, yeah, we're never going to find just a bare jack for this. And I was half right. So I had a close look at this jack here. I looked at the overall design of it, and I also looked at the pinout on the bottom of it. We've got two plastic anchors there. Let me find the light. There we go. We've got two plastic anchors and then 5 pins. So I started looking for stuff that matched that. And there were some ports available on eBay and from component websites, but the ones that I found either didn't match the pinout, or when I did actually find some on some component websites, there were minimum order quantities of like 20, and they were £4 a pop. And like paying £4 for a replacement port, I've got no problem with that, because for single one-off repairs, that doesn't really matter to me. That's just the cost of the business, and like that's the cost of the parts, which you're handing over to the customer anyway, whatever. However, if I've got to order 20 of them, suddenly them being £4 a pop is now a problem. That's now not feasible. So then I came up with another idea. I was like, could I scavenge a port from somewhere? And I thought, so I started looking for optical converters. And I found the cheapest one on eBay I could find, which is this. It's a USB wireless, everyone. It's a digital to analog converter. So for this one, it takes a optical it takes a SPDIF input via optical or coax, and it spits out an analog output. So you can convert your optical line to just twin phono. So this probably is garbage quality, but we don't care if it's garbage quality because it cost me about £5 and it has a brand new optical port on it which I can scavenge. So we've now effectively, in a very wasteful manner, bought a replacement port. All I have to do is remove this without completely butchering it. So I did this, and I spoke to my friend and colleague Caradog about how clever I felt about it, and he said, "Couldn't you have taken one off of one of your many scrap motherboards?" And I said I don't want to talk about this anymore. However, yes, once again, as you can see, we've got 2 plastic anchors and a 5-pin arrangement. Now, the difference is, yeah, we probably could have scavenged this one and made it fit. However, the difference is that now I have one that is actually brand new. This one has probably never been used before. No one uses optical. Also, hi to the 2 people in the audience who use optical. I used to use optical quite a lot on an old setup of mine, so I'm not unfamiliar with it. However, not a lot of people use it. So that port has probably never been used, but either way, now we definitely have a brand new one. So I've waffled long enough. Let's open this up and have a quick look and confirm that it is what I expected it to be. The eBay listing for this did show a picture of the insides. No! A picture of the insides that doesn't match. Hoisted by my own petard, this is completely different. It's a good thing I've got that motherboard, isn't it? I didn't plan this. Okay. Right, a little bit sad about that. That hasn't gone to plan. That hasn't gone to plan at all. I've now wasted £5 on what's probably a garbage piece of audio equipment that I'm never going to use. Okay. Well, I guess I'll just put this to one side, and now I guess we're going to do some scavenging from an old AM3 motherboard that doesn't work. However, I think first we're going to try and remove this without butchering everything. So let's carry on disassembling this. I'm waffling a lot in this video, but the thing that I wanted to talk about the most in this video was not just this repair, but also the idea of how to approach something where you're looking at something going, where am I going to find the part? And I wanted to introduce ideas of looking in unexpected places for replacement parts. A la, sometimes you could just buy cheap Chinese tat, not because it will be a good replacement, but it might have parts on it you can scavenge for something more useful. So, right, we've only got 5 solder points on this, so I'm going to try and soldering iron hero this out. As a practice run for the motherboard, because I would like to not use any hot air because this is plastic. It is possible to hot air stuff without damaging plastic, but I don't want to run the risk. I also might need to sort out this backing because the camera is very black. So we've got a black circuit board and a black component and a white background. That's not ideal. Let me see if I can do something about this. So what I'm going to do, I'm going to heat up my soldering iron, and I'm going to use this low melt solder and just reflow these joins with low melt solder, and that will bring the melting point down, which will mean that they will take longer, they will stay molten for longer, and I can probably just keep them all flowing with the soldering iron and just pull this guy off. We could butcher this guy out, but I want to do a practice run. So what do I think this board is? How many layers is in this board, do I think? Could just be double-sided. Let's run lower heat first. Only run as much heat as you need, so I'm sitting at 370 at the moment, I think. Yeah, 370. Here we go. Doesn't matter if we blob the solder and make bridges. If anything, that will probably help me out. because it means that all of the heat keeps transferring. Okay, so I'm just going to do this, keep it all flowing, keep all the heat in there, and start trying to pull this guy out. Oop. There we go. Oh, we left a pin behind. The last pin got pulled out. That's okay. We can yank him out. Tweezers. Go. That's that guy out. We'll need to clear these holes in a minute, so I'll probably go for the desoldering gun for that. Cheat. Right. Am I going to try and pull this thing apart to see what's inside? I think I will. So I'm just going to break this guy open, because I'm curious. Yeah, so these two ones, those don't connect to anything. It looks like those are just anchor pins. Whoops, I'm way off shot here. So it looks like these bits were just anchor pins, and it's only a 3-pin connection. So that does make me kind of want to look at this one again, because the 5 pins aren't necessary. All we actually have here is an LED and a light sensor, so a photo I forget what it's called. My brain is very fried this week, so please excuse me. There we go. So on an LED, the chip is on the cathode, which is the negative leg, and there's a tiny wire that extends to the anode. And we can actually see this. Let's go in closely. So you can actually see there we've got a chip with a wire stretching across to this leg. So this is the anode, and this is probably, I don't know which one is going to be the emitter and the receiver. The important thing is one of these emits light and the other one receives light, is my guess. And we can actually see, oh, there's multiple things going across there. See, now it's got me to wondering. So you can see we've got a chip here, and that's got a bond wire stretching over to here. And then it also has bond wires going over to other legs as well. So I'm not 100% certain how that works, if I'm honest. This one to the center isn't connected, but it has a bond wire over to there, which means it does actually have an indirect path to this pin. And then that one has a bond wire going down to this pin. So one of these is probably forming the receiver, while the other one forms the emitter. I'm not sure which would be which. If I had to guess, I would probably say that is the TX, the transmit LED, that emits light, because you want a really big beam of light going down there. And then I would probably say that this bit back here is the receive. That's probably the receiving bit that is sensitive to light. So when light comes back down the optical cable, it hits this lens and just bounces all around in here. Editor's note, I'm not sure if these optical connectors are bidirectional or whether you get a specific transmit and a specific receive one. If it's the latter, then this would obviously be a transmit one, and what we're seeing in the center is obviously the LED, and the chip is likely just the digital audio driver, meaning that the sound card can just feed a digital audio signal directly into this, and it will drive the LED by itself without additional circuitry. Likewise, if they are bidirectional, it's possible that that is also handling the receiving, but I'm not actually sure. This might explain why there are some quote-unquote 5-pin connectors and some 3-pin connectors, denoting whether they're transmit or receive. If anyone knows the real answer to that, I'd be delighted to know in the comments, because I did a little bit of searching around, but I couldn't find anything other than just very broad descriptions on what TOSLink was. However, I'm speaking out of pure ignorance here, but yeah. Oh well, I hope that was kind of interesting. Well, that was kind of interesting. Let's try and clear these holes. So I'm going to turn on my desoldering gun. Actually, I'm just going to see if I can wick them down first. When you have a desoldering gun, it becomes extremely tempting just to try and desoldering gun everything and just forget that wick is a thing and when used properly might just do the job. I'm going to put a bunch of flux on there because my wick is pretty bad quality and is not pre-fluxed. Alright, let's wick. Oh, I need more heat. Oh, those are coming up clean though. We're good, we're good. This is cheap wick that I'm using here. However, I have discovered that you can get very far with cheap wick with good technique, a la using flux and also just pressing the wick in slightly just so it expands a little bit. And those holes, oh, we've got a little bit of schmutz on top there. Let's just move that. I think those just came up clear first time, which is very good. Alright, so we've removed the damaged port and we have a clean bit that's ready to go. I will actually just clean that top bit up because when we put the new port in, I want that area to be clean because we won't have to put any solder there. I'll use a Q-tip with some alcohol on just to tidy up the flux residue there. Burnt flux leaves a very hard residue. So if you're having a lot of issues removing your flux residue, it's probably because you're burning the flux. However, this can be quite difficult to avoid because a lot of flux will start burning at like 350, 370, that kind of temperature. But when you're doing repairs on heavier circuit boards with small soldering irons, you kind of need high temperatures in order to actually work. So this is possibly symptomatic of just using underpowered soldering irons, which in a way we do, or I do. They work, but I do wonder if running a big high power hacker would be easier. Right, I'm going to use the same technique to extract this port that I've just practiced. This one's going to be a little bit trickier because this board is obviously significantly heavier and will soak up significantly more heat. So I'm going to give it the beans this time. But hopefully we should be able to come out with exactly the same technique. Put some nice big blobs of low melt solder over all of those pins. And just keep the heat there and just work the heat down through the pins. And I'm now just wobbling this guy loose. Some assist of hot air from the hot air station might help here a lot. Just running it on like 200 just to warm the board. However, I've only got two hands, so I think that might be needed actually. I'm going to risk it. I probably have another motherboard somewhere that has one of these on. So, what are we going for? Let's go 250. Here we go. As soon as this is all molten, yeah, that's all molten. Yeah. A little bit of flux, keep things nice. I might just need more heat. In fact, I think I need more heat. I'm going to 300, 320, 350. We're hot airing this out now. I'm worried about those holes where the anchors would be. Yeah, it doesn't want to go. This is exactly why I didn't want to hot air. I've got a lot of heat in the board now. I'm just going to come straight back in with the iron. Have I butchered it? No, we're okay. Coming straight back in with the iron while the board is hot. If it's not apparently obvious, I'm making this up as I go along. Come on, move. The port is wobbling all over the place, but the pins don't want to go. Oh, we're getting there. It's coming. It's on the way. There we go. Whew. Good. Oh, that's not too bad. I saw some shininess on the plastic and thought I was melting the port. However, that was just where the flux that I'd added had gone through the anchor holes, and it just looked like I was starting to melt that. Cool. Let's just clean up those pins a little bit. So when we have a look at this guy, if I just gently push that door open, you can see that pushes open to reveal the interior and the actual optics inside. Cool. Right, moment of truth. Is that just going to go straight in for me? I think there's still too much solder on some of these pins that are making them too thick for the holes. So I'm gonna wick those. I think one of those holes is still blocked. Yeah, that center hole is still blocked. I need to clear it. I'm gonna use some flux and some more wicking just to see if we can get that guy free. That might just be dried burnt flux down there, to be honest, but if it is, then the wick will pull that out anyway. No, that center hole is still giving me trouble. I'm going to try and heat it as I push the block in. Let's try and be vaguely on shot while I do this. This is exactly why you need clear holes. I think it's just the one hole holding me up though, so I'm going to risk flowing some fresh solder into there so I can get the hole to be molten. If you have multiple blocked holes, this is not a good strategy. Alright, I think I just got this thing piloted. Right, that is the 3 data pins in, so now we're just lining up the rest. That in? Yep, okay, that is in, so just going to make sure that is happy. Alright, that's now flat on the board, so the next question I need to ask is this going to line up with the back panel? Because if it doesn't line up, then this port is no good. So we're going to check that before we commit to this. We've only got one pin holding it in right now. So if we get this guy lined up. Oh, it's too high. It's too high. If I turn that around so it's the right way up. Done. I wonder if I can we bully that? What I'm going to do is I'm going to trim off the feet on the bottom of this port so it sits lower. That gets me at least another millimeter. I think we only need like 2 millimeters tops. So if I can just get this guy to go a little bit lower. I bet that when I post this video, there's going to be people in the comments saying, oh, you could have found the correct one here for £2. And I just happened to not be looking in the right place, but whatever. Improvise, adapt, overcome. Right, let's try and put that in again. I did not clear the hole, so fresh solder to get it going. Right, now we're even more flush on the board. How are we doing? Oh, we're so close. We're so close to clearing that. That's basically on. Whoops. That's basically on. I think I'm going to commit to that. Oop. This repair turned out to be a little bit more experimental than I had originally intended. However, I tend not to record when I'm doing something a bit experimental. And the last couple of times, I've ended up with what I think have been some really good repairs, and I've been really sad that I wasn't recording. So this time I was like, sod it, we're going to record it, and whatever happens, happens. Okay. Let's do a little bit of cleanup there. Right, that guy's soldered on pretty good. We've put a new port on this now. I'm going to put this backpack plate on. And that guy's just going to bend down a little bit. It's not. Now it's anchored in. It doesn't want to move. Okay. Man. If I could just file like a millimeter off the top of that, we'd be golden. Alright, I cheated. I took some power tools, and by power tools I mean a Dremel, a steady hand, and some expendable craft blades. And I've just taken like a millimeter out the top there. So now, when we put that on, that just fits over. So it's not quite as slick as the original would have been, but I think that's all right. Personally, I think that's quite acceptable. And by the time it's all in place, you never know. As long as it works, of course. Hopefully it works. Good. I'm putting this back together. All right. That is all reassembled, complete with peel that hasn't been done. I'm very sad about that. Could the owner of this sound card please do the peel? Make us all happy. You have the power. It's within you. There's another one there. This is free advice. Anyway, right, that is all put back together again. I've got all the screws in the back of that. And as you can see, that looks pretty clean, I think. So the only thing left to do now is to test it. Now, I don't have an appropriate test setup to hand, but I've got one at home. So through the magic of video editing, we will now teleport to my home where this is installed in my computer, and I have it connected up to a SPDIF output receiver. Teleport noise. So there we have it, everyone. That is all sorted. So we've successfully replaced that. It is all fully functional. It's not like the exact same fit, but the hard part about these jobs is finding exactly the right port. And that's going to be a tough job for something like this. But we've got a working sound card out of this. So the owner of this sound card, who's, I'm assuming, using that optical out to an optical receiver, like a surround sound receiver or something like that, can now go ahead and continue using it. Thank you very much for watching, everyone. Thank you, all, as always, to all of the channel supporters on Patreon, YouTube memberships, Twitch subscribers, all the rest of it. And I'll see you guys next time. Bye for now.